All right, so we already started the investigation. Here is your summary video. Now I'm going to break this into several different videos, not just one really big one. The purpose of this isn't to give you all the answers. The purpose of this video is to allow you to check your work and see if you're doing everything correctly. So, without further ado, let's talk about question A. So we have this beautiful chipboard here, and we have, I see, 6, 7, 8. So I have 8 black chips. And I'll write this in a neutral color. So I have 8 black chips. The original board, we start with 8 black chips. And each chip is worth a positive 1. Each red chip is worth negative 1. All right, so I'm adding to this 1, 2, 3, 4, 5, 6, 12 negative chips. So I have 8 plus negative 12. Well, 8 plus negative 12 is equal to, well, let's see. Let's pair them up. I don't know off the top of my head, so let's pair these up. I have a better idea. It'll work a little bit better with the visual. Good thing I'm not wearing a cutoff, because then you can see my belly button and no one wants to see that. All right, so here we go. So we have 2, 4, 6. We have 8 black chips, and I'm adding to that 3, 6, 9, 12. So now I'm able to physically pair these up into zeros, because a positive 1 plus negative 1 is 0. So when I've paired them up, okay, I'm not OCD, but the OCD in me wants these to be straight. So straight they will be. All right. And what am I left with? I'm left with 4 negative chips. So therefore, hello again. So therefore, 8 plus negative 12 is going to equal negative 4. All right. Well, let's see what happens if we add 5 black chips back to the board. So if I add 5 black chips, well, now I can pair off more zeros. So that would mean the original board, and notice how I have the 1 left over. So that means the original board, which was negative 4, plus 5 black chips is equal to, well, we had 1 black chip remaining. Okay, so now we're going to start back over with the original board. So I'm going to take the 5 chips I added, take them away. And so the next question, question 3, wants me to remove 5 red chips. So let's remove 5 red chips. 1, 2, 3, 4, 5. So I've removed these, put them off to the side, and I'm left with 1 black chip. So that means if I have a blank screen, okay, so here's what we're going to do. Instead of turning it back on, do you mind trying to log back in? I'm going to do it on pencil and paper, the old-fashioned way, and you can watch it because I can write backwards. All right. So originally, we had negative 4, right? So that was the value of the chipboard. Then we subtracted 5 negative chips. So that's subtracting negative 5. And when we did that, we ended up with this 1 black chip, so positive 1. Hopefully you can see that okay. No, it would be better if I was using a pen. Let me see if I have a red pen. I'll be right back. Oh, better yet, a green pen. I love writing in green. It's not my favorite color. However, writing in green seems awfully soothing and not as abrasive as writing in red. So you should be able to see that better. All right. So, what does that mean? Well, notice how we started out with a negative number. When we subtracted a negative, we ended up with a number that was larger than what we originally started with. All right, that's interesting. All right, so let's go back to the next question in the book. Of course, I got that.
Oh.
So I'm back live. Excellent. So hopefully this is as seamless as humanly possible. Obviously this is not going to be quite YouTube viral video quality. But let's be honest. How many people are doing viral videos on math instruction anyways? All right. We're almost there. All right. So our next, so I'm going to take the chipboard back to its original value. All right, you can't see it, but trust me, I just did it. All right, so now we're going to remove 3 black chips. Well, if I remove 3 black chips, take them off to the side, well, now I have 3 more, so okay. So what does that mean? Well, if I subtract 3 positive, I ended up going deeper into the negative, didn't I? Now I'm at -7. So that means that -4 minus, and I took away 3 black chips, so minus +3, that ended up at -7. All right, let's do the next one. Add 3 red chips. So going back to my original, go back, Vicini says, go back to the beginning. So I go back to the beginning. All right, one of the greatest movies ever, if you figured out what movie it is, good for you. Your parents did well raising you. All right, so we're adding 3 red chips. 1, 2, 3. Well, now we just have -7 again. That's interesting. So if we started at -4, and I add -3, I get -7. Oh my goodness. So that's what we talked about yesterday, isn't it? Subtracting a positive is the same thing as adding a negative, which will allow me, a human with a brain that sometimes work, to interchange or use subtraction and negative numbers interchangeably, which makes actually things much easier. You'll see later, especially in 8th grade math. We do it all the time. All right, so what else did we notice? I'm going to redo this one so we have to look for connections. So we started with -4, we added 5 black chips. When we added 5 black chips, we got to 1. When we started at -4 and we removed 5 red chips, we also got 1. Oh. So that means there's a connection between adding a positive and subtracting a negative. So adding a positive gave me the same result as subtracting a negative. Oh. That might be helpful to know later on. Great. So that's what the patterns that we saw. You should definitely have noticed this piece here. All right, excellent. So I'm going to stop this video, and then I'm going to do the next couple sessions as well.